In this video, we'll walk you through the key elements of an effective data warehouse strategy, from designing your data model to implementing robust data governance. Whether you are looking to optimize your current setup or starting from scratch, we'll cover essential best practices and technologies to help you build a strategy that powers better decision-making. Building a successful data warehouse strategy involves several crucial steps, including define business objective, data sources identification, data integration and ETL, data warehouse architecture design, data governance, security, compliance, business intelligence tools and reporting, performance optimization, cloud versus on-premise versus hybrid. Let's understand all these steps. Business objective. In business objective, we have to define the goal and considerations. When explaining the goals and considerations for a data warehouse, it's important to clearly articulate both what the end objectives are, that is the goals, and what factors need to be kept in mind, that is considerations, throughout the design and implementation process. Here's a structured way to explain these concepts. First, align the data warehouse strategy with the organization's business goals and decision-making processes. Then focus on what specific business questions need to be answered, for example, sales, marketing, finance department. Let me explain with an example. A retail company might want a data warehouse strategy that helps track sales performance, inventory levels, customer behavior, and marketing campaign effectiveness. Next is data source identification. In any data warehouse project, identifying the right sources of data is critical. A data warehouse brings together information from various systems to provide a unified, comprehensive view for analysis and decision-making. We need to carefully identify both internal and external data sources. Internal data sources are the core systems that organizations rely on for their daily business operations. These sources include transactional databases, enterprise resource planning, ERP systems, customer relationship management, CRM systems, and other internal applications. External data sources are those that originate outside of your organization. These sources help enrich your internal data, providing additional context, trends, and insights that support decision-making. They can come from public data sets, that is social media, third-party providers, or external market data. Next is data integration and ETL. Data integration and ETL processes are foundational to the success of a data warehouse. They ensure that data from multiple sources is combined, cleaned, transformed, and loaded in a way that it can be easily analyzed and accessed for reporting, forecasting, and decision-making. By implementing effective data integration and ETL strategies, organizations can gain accurate, timely, and actionable insights from their data. Now, dive deeper into the ETL process, which is the core of data integration for many data warehouses. In data extraction, data is collected from multiple sources. These sourced can include databases, APIs, flat files, etc. In data transformation, involves cleansing and enriching the extracted data to ensure it in proper format for loading into target system for analysis. This phase often involves using ETL tools or scripting languages like Python or SQL to perform operations. In data loading, the transformed data is loaded into target data repository, typically a data warehouse. Three types of loading are full load, incremental load, and real-time loading. Next is data architecture design. It defines the structure and architecture of the data warehouse, ensuring it meets both current and future business needs. When designing a data warehouse, one of the most important decisions you'll make is how to organize and structure your data. The way your data is architected impacts how easily it can be queried, analyzed, and used for decision-making. I am going to explore different data architecture concepts, including the star schema versus snowflake schema, the distinction between dimensional and fact tables, and how a data lake differs from a data warehouse. The star schema is the simplest and most common schema for data warehouse. It has a central fact table and multiple dimension tables. These dimension tables are directly connected to the fact table, forming a star-like structure. Fact tables are the core of any data warehouse schema. They store measurable, quantitative data, such as sales totals, profits, or transaction amounts. These values are usually aggregated in reports. While dimension tables that store descriptive information such as customer names, product details, or time periods. A data lake is a large, flexible storage repository that stores raw, unprocessed data from multiple sources. It can store structured, semi-structured, and unstructured data. While a data warehouse is a structured, optimized storage system that contains organized, cleaned, and processed data. It is designed for analytical querying and reporting. Next is data governance, security, and compliance. Data governance refers to the policies, processes, and standards that define how data is managed, accessed, and used across an organization. It ensures that data is accurate, reliable, and properly classified while setting clear rules on who has access to it and how it can be used. Key aspects of data governance are data quality, data ownership, and metadata management. Data security refers to the practices and technologies that protect data from unauthorized access, breaches, and loss. Given the value of data and the risks associated with cyberattacks, ensuring that data is secure is a top priority for organizations managing a data warehouse. The key aspects of data security are encryption, access control and authorization, authentication. Data compliance refers to adhering to the legal and regulatory requirements surrounding the collection, storage, and processing of data. Many industries are governed by strict laws and regulations that dictate how data must be handled to protect individual privacy, ensure transparency, and prevent misuse. The key aspects of data compliances are data privacy law, industry regulations, data retention and audit. Data governance, security, and compliance are the pillars of a well-functioning data warehouse. Together, they ensure that data is not only accurate and accessible but also protected and compliant with regulatory standards. By prioritizing these aspects, organizations can manage their data responsibly, minimize risks, and create a solid foundation for business intelligence and decision-making. Next is business intelligence tools and reporting. The most popular business intelligence tools are Power BI, Tableau, ClickSense, and Looker. Reporting capabilities in a data warehouse allow organizations to turn data into actionable information for decision-making, performance tracking, and strategic planning. Data warehouse supports several types of reporting capabilities, ranging from simple reports to advanced analytics, depending on the needs of the organization. Some common types of reports include ad hoc reports, scheduled and automated reporting, real-time reporting, dashboard reporting, and KPIs. Next is performance optimization. Performance optimization in a data warehouse is essential because businesses rely on fast, efficient access to data for decision-making. as data grows and more users access the system, ensuring that queries run efficiently, reports load quickly, and overall system performance is maintained becomes increasingly important. Without optimization, slow query times, system bottlenecks, and poor performance can undermine the effectiveness of the data warehouse. Performance optimization can be approached in several key areas within a data warehouse: data modeling optimization, denormalization, materialized view, query optimization, indexing, ETL processes, and join optimization. Next is cloud versus on-premise versus hybrid. Let's understand the differences. Cloud data warehouse. A cloud data warehouse is hosted on cloud computing platforms such as Amazon Web Services, AWS, Google Cloud Platform, GCP, or Microsoft Azure. It allows organizations to store, manage, and analyze data without maintaining physical hardware. While an on-premise data warehouse is hosted and managed within an organization's own data center. This model involves investing in and maintaining physical hardware, servers, and infrastructure. The most popular on-premise data warehouse solutions are Oracle Exadata, Microsoft SQL Server, Teradata. While a hybrid data warehouse combines both on-premise and cloud-based solutions, allowing data to be stored and processed across both environments. It enables organizations to benefit from both worlds by integrating local infrastructure with the flexibility and scalability of the cloud. The main question is, when to use each? Let's understand cloud data warehouse. If you need scalability, flexibility, lower upfront costs, and are comfortable with a third-party provider handling security and maintenance, it's ideal for startups, rapidly growing organizations, or those with fluctuating data needs. When to use on-premise data warehouse? If your organization requires complete control over its data and infrastructure, has strict regulatory requirements, or needs to manage sensitive data in-house for privacy and security reasons. When to use hybrid data warehouse? A hybrid model is ideal if your organization needs the flexibility to manage both sensitive and non-sensitive data across different environments. Today, we've explored the essential components of a robust data warehouse strategy, from defining goals and identifying data sources to designing the architecture, optimizing performance, and ensuring data governance, security, and compliance. Each of these areas plays a critical role in building a data warehouse that can effectively support business intelligence, reporting, and decision-making. Thanks for tuning in, and don't forget to subscribe for more insights on data and analytics strategies.